So today we're going to be looking at 3.8 inverses, and this is video number 1. We're going to find inverses, identify properties of inverses, we're going to graph them, and learn how to recognize their properties from graphs, things like that. So for example 1, I give you a function called h, and it's a set of ordered pairs. And so when we go to describe the inverse of h, a couple of things. First of all, by definition, an inverse is where you're simply going to switch x and y. And the notation for inverses is h at -1. Or if this was f, it would be f at -1. A lot of people confuse this and think we're raising it to the negative first exponent. We are not. This is simply the notation for inverse. And so h at -1 would be, if I switch x and y, I still get 1, 1. That one stays the same. 2, 4 becomes 4, 2. 3, 9 becomes 9, 3. And 4, 16 becomes 16, 4. Is the inverse a function? Well, I need to look at this and say, does each input have exactly one output? It sure does. So yes, the inverse is a function. And then it asks me to describe h and its inverse in words. So h is the set of ordered pairs x, y. H to the negative first power is the inverse of h and is the set of ordered pairs y, x. So the simplest definition of an inverse is for you to realize that we're switching x and y. And we also need to remember that my notation for inverse is h to the negative first power. That's what it looks like, okay? Let's go to example 2. Example 2 says find an equation for the inverse of the function described by y equals negative x squared plus 4. So whenever you're finding an equation for the inverse, my first step is, of course, to switch x and y. Because by definition, that's what an inverse is. So when I switch x and y, I get x equals negative y squared plus 4. Right, and then my second step is going to be to solve for y. So I'm going to take this equation, x equals negative y squared plus 4, and I'm going to solve for y. So to do that, I'm going to subtract 4 from both sides, and I get x minus 4 equals negative y squared. I really don't want negative y squared, so I'm going to divide both sides by negative 1, and I'm left with negative x plus 4 equals y squared. And then to get rid of that square root, the squared, I'm going to take the square root, but I do need to remember that I get, because I put the square root in, I have to remember plus or minus in my answer. So my inverse for x equals negative y squared plus 4 is y equals plus or minus the square root of negative x plus 4. Part B asks me to sketch a graph of y equals negative x squared plus 4 and its inverse on the same set of axes. Let's remember that the inverse is y equals plus or minus the square root of negative x plus 4. So what I thought we would do is go to the graphing calculator so that we can see all these parts of the graph, and then we'll sketch them on this graph. All right, so I've put each of the equations. My original equation is negative x squared plus 4, and then my inverse actually has two parts, a plus and a minus part. So I put both of those into y equals, and now I'm going to graph. So my original will be in blue, and then my inverse will be in the red and the black. So let's see what I get. Okay, so notice that my inverse looks sort of like my quadratic turned on its side. So I'm going to sketch that. I'm going to look, and I'm going to go ahead and just draw a slight sketch of this by looking at that on my paper. And again, it's a sketch. It's not perfect. Maybe I can look for things like y-intercepts to make sure I hit those. That will help me to be slightly more accurate. So we're just kind of sketching this right now. Is what we should be doing. All right, that's not the best. I'll show you mine. Inverse a function. So here's my graph. First of all, I have done the pink is the original and the orange is the inverse. Is the inverse a function? No, it is not a function because it fails the vertical line test. Look at that orange graph. It does not pass the vertical line test. So then my next question is, so every time we want to find out if an inverse is a function, do we have to graph it? And the answer is no. What we can do is we can check the original. So to find out if an inverse is a function, simply graph the original. Okay, graph the original, which is the pink graph. So just graph the pink graph. Simply graph the original and perform the horizontal line test. You might not have even known there was one. And perform the horizontal line test. If it passes, inverse is a function. If it fails, the inverse, not a function. Now, here's the confusion that everybody has. The horizontal line test is performed on the original, meaning the pink. The horizontal line test is performed on the original, which is pink. And if I did a horizontal line test on this pink graph, I can see it would not pass. Therefore, the inverse is not a function. So the horizontal line test is not performed on inverses. It's performed on the original to make predictions about the inverse. So that's really, really important to note. We're going to write that up here. So horizontal line test is done on originals to make predictions about inverses. Notice we do not perform the horizontal line test on the inverse. It's to tell us about the inverse. Okay? It's just a lot easier for us to, if this was on a non-calculator test, you know this is a quadratic. You know what a quadratic looks like, and you know if you did a horizontal line test on a quadratic, it fails. Therefore, you know its inverse is not a function. And you don't even have to go to all the trouble of graphing the inverse. Okay? All right, our next example, example 3. Let f of x equal 1 divided by x plus 3 plus 4, and find the equation for the inverse of f. All right, so let's do that. Remember, our first step is to switch x and y. So x equals 1 divided by y minus 3 plus 4. All right, so as I'm trying to move things away from the y so I can solve for it, the first thing I'm going to do is subtract 4. So I have x minus 4 equals, because I subtracted 4 here and here, by 1 divided by 1 minus y over 3. 1 divided by y minus 3. I don't know why I couldn't say that. Okay, so now we have to solve for y, but the problem is it's in the denominator. You can't solve for a variable when it's in the denominator. So our only choice is to get it out of the denominator. The only way to do that is to multiply both sides by y minus 3. Now realize on the right, those y minus 3's are simply going to cancel and we get equals 1. On the left, this y minus 3 is being multiplied by this entire quantity, x minus 4. So I'm going to have to use FOIL. My first terms, I get xy, and then I get minus 4y minus 3x plus 12. Okay, still trying to solve for y. Well, since I'm trying to solve for y, I could at least move the 3x and the 12 to the other side, plus 3x plus 3x minus 12 minus 12. These cancel, and I'm left with xy minus 4y equals, I'm going to write my 3x part first. We usually do our variable first, minus 11. Okay, so just to review, we multiplied both sides by y minus 3 to get that y up into the numerator. Then these y minus 3's canceled, and over here on the left we had to use FOIL. I did y times x. I did 4 times, actually negative 4 times y, negative 3 times x, and negative 3 times negative 4. That's how I got these 4. Then I moved the negative 3x and the positive 12 to the other side because they don't have a y in them. And that's how I got to this point. Now, what I need to do is I'm still trying to solve for y. I need to get y alone. So I'm going to actually pull y out of both of these. Since both of these terms have a y in them, I'm going to put the y in the front. I'm factoring it out. And I'm left with x minus 4. Because if I was to multiply, what I did was I simply pulled the y out of each one. This would be x times y, negative 4y. And I still have 3x minus 11 on the right. Now I still have to solve for y. So the only thing I have left to do is divide both sides by x minus 4. And there is my inverse. Y equals 3x minus 11 divided by x minus 4. That is the inverse